X fourth roots of z equals 16 cis 120. Okay?
Okay, well, why don't you do the weird formula up there?
Okay, I'll do the weird formula to get the first one. I'll also provide a visual.
Well, I can't see that. So
Okay. My apologies. My visual will be less helpful than I
So
assume.
you do 120 divided by 4?
You're getting there. Hang on a sec.
Oh wait, no, never mind, I lied.
No, you do. You do. But give me a sec. Okay, 120 degrees is up this way somewhere, right?
Yeah.
And I'm going to put 16 way out here. Okay? Now, I'm going to get the first root with DeMoivre's theorem
Wait,
by
why
this
is that
formula.
there?
Pardon?
Why is that up there?
Because I need a lot of room. I want to make this length 16 very far. You'll see in a minute, I hope.
I don't, but okay.
All right. Okay.
I just don't understand why the line is there.
Well, 120 degrees is 90 plus 30 more.
So you can just graph it like that.
Well, that's the number, but now I got to find the four roots of this.
Okay.
Okay, the fourth root. So I'm looking for the fourth root of z. So that's going to be the fourth root of 16 cis 120 over 4, and that'll get me the first root. Okay? What is the fourth root of 16?
2.
2. What is 120 divided by 4? 30. Okay, so my first root is over here at 30 degrees, and it's only 2 units away from the origin.
No, they do.
Okay? So that's why I put it over there. That's why I made 16 way out here, because I knew the 2 was going to be the answer. Now, that's one of my roots.
Wait,
Hold on, but
we're
why is it off?
4, right?
Yeah? Yes, we're looking for 4 of them. And we found 1. Martina?
Why is it not on the...
The only ones that stay on the line are the real ones. The unreal ones,
But how do you know how to draw it like that? Because
I
of the
just-
angle?
sweetie, I'm guesstimating.
No, not that one. I'm talking about that
The
one.
angle? Yeah, I'm guesstimating. If this is 16, this looks like it's about 1/8 of that, and that looks like 30 degrees to me.
Oh, okay, yeah.
I'm not pulling out my protractor and my ruler for y'all. Sorry,
Yeah,
just
that's-
because of time.
it's all good.
Yeah.
I'm
So
not
then
either.
do you need to do three more of those?
I gotta find 3 more, so let's think about this a sec.
But can't you just go 30 more, 30 more, 30 more?
I thought
Yep,
it was 1.
well, wait a minute. They're all gonna be on this
I thought it
circle,
was all gonna be
and they're gonna be evenly spaced.
So
There's 4 of them.
30, 30.
Okay, well, no, not like that. Hang on. Guys, slow down.
No, it's 180.
Okay, what is 360 divided by 4, Drew?
Oh, it was 121.
You see a little?
It's 90.
Yes, sorry.
It's
Yeah,
90.
it's 90. Okay, so that means all the other answers are going to be 90 degrees away from this one. Okay, so let's go down here. Let's go down. Let's keep going counterclockwise. 30 plus 90 would be
120.
120. So another one was on there. How about that? Okay, now that's 2 cis 120.
150.
Well, now add 90 to 120.
I mean, 210.
210, which makes sense because that's the flip side of this one. 2 cis 210, and then add 90 to that.
300.
300, so that's at the other end of this one. Okay? So here are my 4 complex roots.
So really, once you have the first one, it's not that bad.
No, it's a little geometry
Is
problem.
this really what we're doing?
Yeah,
Like, seriously?
yeah. I mean, I can pick numbers to make it uglier,
No,
but...
I'm just, I was saying, like, seriously, like, this is it.
I didn't say it was the hardest thing all year, I just said it was really weird and my favorite.
Oh, well, I like it.
I do too.
What if you have like something that would just be like the fifth root of one, like a really, really like weird number? You just try to guesstimate as close to.
Yeah, if you have to plot it, I'm not going to make you plot anything like the 5th root of 723. Okay?
Oh,
But I would certainly make you plot the 5th root of 32, because that's 2 to the 5th.
Okay, well, I mean, are you going to give us whole numbers that we have to plot? Like,
Yeah, unless I give you some serious technological assistance, which I'm not looking for yet. But this does work for all decimals and weird numbers too.
90.
Okay, there has to be 4 of them, because it's a 4th root. Okay? And they have to be evenly spaced around a 360 degree circle. So what's 360 divided by 4?
Okay.
90. So I knew from here I had to jump 90 degrees, 90 degrees, 90 degrees, and then be back where I started. You always have to be back where you started too.
are you giving us polar graph paper on the test?
Yes, absolutely. That'd be insane not to. something like this. You want polar graph paper for something like this, right?
I don't
Okay.
need it for not that bad.
I do. If I wasn't on a blackboard, it'd be such a mess.
Wait,
That's a
so
whiteboard.
I have a question.
Exactly.
If you had like a polar graph, like pull out that polar graph.
Okay, pull out the polar graph paper. James, follow me over here.
Everybody duck out of camera.
Yeah.
Hold on, what are you doing?
I'm asking a question.
Yeah.
Alright, so if you were to graph 2 cis 30, would you have to go out the 2 circles? Like not have
Yes.
to, but that would be what you would do if you were.
Yeah, if you're using a 1-to-1 scale, yes. So there's my 30 degrees, because remember I said these are 15 degrees on this one each? So there's 2 units out, cis 30.
And then you keep going, and that's how you graph it the entire time.
Yeah. And these are my 4 points. Here's my 2 cis 30. Here's my 2 cis, hang on, 120. Here's my 2 cis 210.
300.
And then here's my 2 cis 300.
By the way, Isabel, just check me if I didn't.
Oh, thank you. Okay, good. So yeah, on polar graph paper, I think this is actually really easy. But remember, these are all the roots of, I can't remotely go out there, 3, 4, 5, 6, 7, 8, I don't know, up here,
You need to
16.
stop drawing on your ceiling.
I do. That'd be 16 cis
Wait,
120 up there.
do
Yes.
you have to graph the 16 cis 120, or does that not matter? Because if you do, then that completely throws off the
I know.
balance of that scale.
I will try and be careful going into your next exam to make sure that if I ask you to graph the original point, I use small enough numbers that it's reasonable.
And are you blatantly just going to say graph this? Also, additionally, the first
I'll make my directions clear, or I'll clarify them if you ask, Adina. Right, which I'm sure you will. All right, so that's DeMoivre's theorem. These things are real. I mean, the term imaginary is misleading. Math is basically, well, math in general is as real as you can find a use for it. And complex numbers and complex analysis is very real. Like I mentioned when we talked last fall about where they come from. There's a proof that if you start with, and I showed you the bare bones of it, if you start with an x-axis, I must exist up here. So anytime you want to describe rotational forces, forces that act at a perpendicular angle, I is very useful. Electrical engineers use this every day because you cannot run a circuit through a wire without creating a perpendicular magnetic force in all directions from that wire.
Great.
They used to use this, as I've said before, in submarine hull design. My father worked on it. Because you can't have a submarine going through the water without water pressure pushing perpendicularly against the hull from all directions. And so complex math was a useful way to describe this stuff.
Is that a submarine?
It's a very bad submarine. It looks like a
I would have thought
nose of a whale.
like tangents would have come in more handy for that.
You mean the idea of tangents in calculus? Oh, they do as well. You do calculus on the complex plane. And believe me, by then you're doing some crazy stuff. Technology has replaced some of this, won't lie. But if you don't understand what the technology's doing, you're going to screw up your calculations somewhere. But all math is real. If someone...
draft, like, submarines don't do that stuff.
No, you know what's funny is actually nobody who does this stuff is thinking through the math when they do it. That always fascinates me. We're going to get something called parametric equations. And I taught a girl years ago, who was one of my best math students ever. She's at MIT now.
Yeah, and she asked about how to do a gutter at a certain...
Well, no, and we got to parametric equations, and she started realizing that parametric equations, which we're going to get to soon, are a perfect description of when she shoots. She was also captain of the basketball team for years.
Right.
They're perfect.
Good at math and didn't play basketball.
Well, here's the problem.
He's gifted.
She was, but you know what? When she started to mix the two, she ran into problems. She said she tried to actually think about the parametric equations that describe a free throw while shooting free throws, and she missed every one. If the guy driving the submarine is thinking about the complex equations that describe the pressure on it, he's going to wreck that submarine. I mean, most brains aren't really well designed to both think